Mentor point of view, explaining the K-fold training video. At end of video, glossary for mentorship session, K-fold with bar plus radar charts. Writing hand keynote from the author, Pradeep K. Suri. The strength of any AI model is not just in its ability to learn from data, but in its ability to generalize beyond it. K-fold training reflects the essence of resilience, training with flexibility, evaluating with integrity. This video is not just a technical demonstration, it's a strategic lens through which AI robustness can be understood by management, implemented by developers, and trusted by stakeholders. Let this model serve not only as a validation framework but as a metaphor for adaptability in today's dynamic business environments. Pradeep K. Suri, author, researcher, consultant, and AI/ML architect. Mentorship program explanation for video, K-fold for mentor. Visual components covered. Bar chart rightward arrow accuracy across folds, K-fold validation. Chart increasing radar chart rightward arrow production readiness metrics, precision, recall, F1 score, efficiency. Brain mentor point of view, teaching objectives. Small blue diamond 1. K-fold cross validation, left panel, bar chart. Concept explanation. Purpose evaluate model consistency across multiple training/testing splits. Visual output bar chart showing accuracy per fold. Teaching emphasis each bar equals one independent test scenario, showcasing model performance. Real-world analogy each fold is a rehearsal, final model is the stage performance. Mentoring tip pause after each bar during the animation to ask, what's the accuracy? Is it stable? Magnifying glass tilted left key learning outcomes. Detect variance between folds. Build intuition for model reliability. Understand how overfitting is identified early. Small blue diamond 2. Radar chart, right panel, production evaluation. Concept explanation. Purpose evaluate model's readiness for deployment. Visual output radar chart with 5 key metrics, accuracy, precision, recall, F1 score, efficiency. Teaching emphasis use radar spikes to illustrate balance versus bias in model outputs. Real-world analogy like a car dashboard showing speed, fuel, and engine health before a race. Mentoring tip ask Ments, if recall is low and precision is high, what does it imply for our system? Magnifying glass tilted left key learning outcomes. Compare business KPIs from different model states. Emphasize balance, all spikes full, versus skew, one spike dominates. Guide Ments on model tuning trade-offs. Compass mentoring strategy for session flow. 1. Start with the concept, introduce K-fold cross-validation. 2. Play the video, let Ments observe fold-by-fold performance, bar chart animating. 3. Ask interactive questions. Why did fold 3 drop in accuracy? Is the model generalizing well? 4. Transition to radar chart. Discuss how consistent accuracy leads to better production metrics. Highlight how imbalances in metrics affect real-world results. 5. Wrap up. Reaffirm why both views, bar plus radar, are essential for deployment. Align AI validation with business impact. Writing hand keynote summary by Pradeep K. Suri, author, researcher, mentor. This video is a mentor's toolkit. It doesn't just show accuracy, it shows accountability. Each fold reflects our model's adaptability. Each radar point speaks about business readiness. If we can teach our Ments to read this visualization like a diagnostic, we are building not just AI engineers but AI leaders. Pushpin final mentor insights. Component use in mentorship. Bar chart teaching model consistency, detecting instability. Radar chart teaching model impact on business KPIs. Animation storytelling tool demonstrates performance evolution. Play/pause button encourages controlled explanation and peer-led discussions. Concept overview. The video introduces K-fold cross-validation, a robust AI/ML model validation technique used to ensure model generalizability and avoid overfitting. The core idea is to split data into K equally sized folds and systematically rotate the training and testing data to evaluate performance across all segments. Brain what the mentor should emphasize. K folds equals K experiments. Each fold acts as a new experiment where the model is validated on unseen data. Bias variance balance. Discuss how this technique reduces variance in model evaluation. Model robustness. Reinforce that consistent performance across folds suggests high model stability. Explain with visuals. Use diagrams from the video to illustrate how data splits into training/testing chunks. Real-world analogy. Think of this like K rehearsals before a real performance. Each fold helps prepare for unknown test cases. Office building commercial use across management levels. Keycap 1 Top management. Business value. Validates AI investment by showcasing model reliability. Confidence in AI/ML systems used for financial forecasting, risk management, and predictive maintenance. Use case domains. Strategic AI model evaluations in healthcare, BFSI, automotive, and retail. Keycap 2 Middle management. Operational deployment. Selects models based on validated performance metrics, example accuracy, F1 score across folds. Drives data-driven decisions and KPI improvement. Domains, ERP decision support, marketing campaign analytics, human resource predictive planning. Keycap 3 Operational teams. Hands-on implementation. Uses K-fold CV to fine-tune models before deploying into production pipelines. Integrates cross-validation into CI/CD pipelines for ML ops. Domains, IT operations, manufacturing, data engineering, real-time monitoring systems. Globe with meridians. Domains of application, with example KPIs. Domain K-fold usage scenario metric of interest. Healthcare predict patient readmission risk ROC AUC, recall. Education forecast dropout risk accuracy, F1 score. Supply chain demand prediction models RMSE, MAPE. Finance credit risk evaluation precision, AUC. Manufacturing predictive maintenance on equipment MAE, uptime %. Retail customer segmentation silhouette score. Glossary for mentorship session, K-fold with bar plus radar charts. Term definition. K-fold cross-validation, a model validation technique where the data is split into K equally sized subsets, folds. The model is trained on K1 folds and tested on the remaining fold, iterated K times to ensure balanced validation. Fold a single partition of data in K-fold cross-validation. Each fold takes a turn as the test set, while the others are used for training. Accuracy, the ratio of correct predictions to total predictions. In K-fold, accuracy is computed for each fold and averaged. Variance, the variability of model performance across different folds. High variance may indicate instability. Overfitting, when a model performs well on training data but poorly on unseen data. K-fold helps detect this issue by testing the model on multiple unseen subsets. Bar chart, a visual representation used in the video to show the accuracy of the model on each fold. Each bar represents one fold. Mean accuracy, the average of accuracy scores across all K-folds. Indicates overall model performance. Radar chart, spider chart, a circular chart where each axis represents a different metric. Used in the video to show production readiness across accuracy, precision, recall, F1 score, and efficiency. Precision, out of all predicted positive outcomes, how many were actually positive? It focuses on correctness. Recall, out of all actual positive cases, how many did the model correctly identify? It focuses on completeness. F1 score, the harmonic mean of precision and recall. It balances both metrics into a single value. Efficiency, in AI deployment, a holistic metric representing the balance between model performance and operational viability, example compute time, stability, cost. Bias variance trade-off, a core machine learning concept describing the balance between underfitting, high bias, and overfitting, high variance. K-fold helps navigate this trade-off. Model robustness, the ability of a model to maintain performance across various data splits. Higher robustness indicates more reliable AI. Business readiness metrics, metrics shown in the radar chart that reflect whether a model is ready for deployment in a real-world setting, example consistent recall in healthcare models. Animation, in visualization, used in the video to reveal results step by step for easier storytelling and comprehension. Mentorship flow, a guided structure used by a mentor to help ments understand AI modeling from both technical and business angles. Diagnostic view, a perspective of analyzing a model as one would analyze symptoms in a system, essential for AI mentoring. Play/pause button, animation control, allows mentors to step through each fold for discussion, making the video interactive and discussion based. Thanks for watching the video.